Hello there. My name is Michael Tawonga Kamanga, your chemistry teacher from 1. In today's class, in today's lesson, I will take you through mixtures. Mixtures, more especially on the methods of separation of mixtures. So far, we have looked at so many methods or processes or techniques for separating mixtures. Just a quick recap. We have looked at the sedimentation, we have looked at the filtration, we have looked at the fractional distillation, we have looked at simple distillation, among others. The idea of mixtures is very, very important because knowing the components of a mixture will always assist us in knowing how we can separate the mixture. So be with me as I'll be taking you through methods of separation of mixtures. In today's class, we'll look at sieving. Sieving as a method of separation of mixtures. Sieving. So in sieving, I will take you through the whole process of sieving, and we'll see how sieving is done to separate the mixtures. And furthermore, we'll also see which type of mixtures can be separated using the process of sieving. So we'll go through sieving and the sieving as a process and the applications of sieving and how is it done. So yes, one method of mixture separation is by sieving. Okay, so allow me to take you through the definition of a mixture and the types of mixtures so that we link this idea with our technique of sieving. So we need to understand the definition of a mixture and the types of mixtures which we have. Now, a solid to solid mixture is a combination of two or more solid substances mixed together. So if two solid substances are mixed together, they are combined. That type of a mixture is known as a solid to solid mixture. So two or more substances which are solid in nature, they are mixed together. They are combined. And in these mixtures, each component retains its physical properties and can often be physically separated. So in mixtures, it doesn't mean that the components of a mixture are chemically joined together, are chemically combined. Instead, they are physically combined. So because of that, they can be separated using physical means. They are physically separated because they are physically combined, physically connected. So in a solid to solid mixture where we have two or more solid, these can vary widely in their composition and can be homogeneous or heterogeneous, depending on how uniformly the components are distributed. So solid to solid mixtures can vary widely in their composition and can be homogeneous or heterogeneous. Meaning to say, yes, you can have a solid to solid type of a mixture, which is homogeneous in nature, where you cannot be able to tell that this is solid A, this is solid B, because there is uniform distribution, there is uniform combination. And the same solid to solid mixture can be heterogeneous in nature. You can be able to tell that this is solid A, this is solid B as the components of your mixture. So this depends on how uniformly the components are distributed. No wonder we are saying it can be homogeneous or heterogeneous. But by the end of the day, remember, we are dealing with solid to solid mixture. So what are these types of solid to solid mixtures? Yes, we have already mentioned here that we can have homogeneous solid to solid mixtures or heterogeneous solid to solid mixtures. So let us see how the two can be described. We should start with homogeneous solid to solid mixture. These are also known as solid solutions. These mixtures have a uniform composition throughout. No wonder they are called homogeneous mixtures, because they have a uniform composition throughout. So they have a uniform composition throughout. And the components are evenly distributed at the molecular or atomic level. So this simply means that you cannot identify the components of these mixtures. So the components are evenly distributed at the molecular or atomic level. Hence, they are homogeneous in nature. They have a special name. We can also call them solid solutions. So they have a uniform composition throughout. Why? Because they are evenly distributed at both molecular level or atomic level. No wonder they are homogeneous. So, can you give me an example of a solid to solid mixture which is homogeneous in nature? Yes, you can type in the comment section and give examples. So here are some of the examples. Alloys such as bronze, which is a mixture of copper and tin or steel. A mixture of iron and carbon, where the metals are melted and mixed to form a uniform structure. So yes, we can have alloys. Alloys are a good examples of homogeneous mixtures. So an example of an alloy is a bronze or steel. Bronze is just a mixture of copper and tin, while steel, it is a mixture of iron and carbon. So indeed, alloys, they are examples of homogeneous mixtures. Now, let us proceed. Remember, our second example is heterogeneous mixtures. We said in heterogeneous mixtures, these mixtures have a uniform composition where the individual components can be distinguished. In homogeneous, there is uniform distribution. But in heterogeneous, these mixtures have a non-uniform composition where the individual components can be distinguished. So you can be able to tell that this is component A and this is component B. It is non-uniform. These mixtures have a non-uniform composition where the individual components can be distinguished. The components are not evenly distributed, and different parts of the mixture may have different compositions. I'll take that again. The components are not evenly distributed, and the different parts of the mixture may have different compositions. So yes, they will have different compositions because they are not evenly distributed. Aha. I hope now you are able to understand the difference between a homogeneous solid to solid mixture and a heterogeneous mixture. In summary, in homogeneous, there's uniform distribution, while in heterogeneous, there's non-uniform composition or distribution. Please take note of that. So, would you please give me examples of heterogeneous solid to solid mixture? Yes, type your answers in the comment section. Okay, we have granite. Granite is an example of heterogeneous solid to solid mixture. Heterogeneous solid to solid mixture. As you can see, we have several components. This is a mixture. This is granite. It has several components. Some are white in color, black, some are brown. Granite is beautiful, isn't it? It is looking nice. It's made up of several substances. So we're saying this is heterogeneous because you can be able to see that this is component A, this is component B. Unlike in alloys, there is no clear, yes, you cannot clear tell that this is component A and this is component B. Let us proceed. Maybe what is another example of a heterogeneous mixture? Solid to solid mixture. Remember, we're dealing with solid to solid mixture. What could be another example of such kind of a mixture? Okay. Yeah, so yes, you can put the answers in the comment section. Let us proceed by looking at the characteristics of solid to solid mixtures. Because in sieving, we are dealing with solid to solid mixtures. No wonder we want to gain more information on the solid to solid mixtures. So quickly, let us look at the characteristics of solid to solid mixtures. The solid to solid mixtures, they have retained properties, variety in composition, and their separation techniques. On retained properties, each component retains its original properties such as color, hardness, and melting point. Why? Remember, in such mixtures, there is a physical combination and not chemical combination. No wonder if we want to separate such kind of mixtures, then we'll go back to the original substances. No wonder we're saying that the substances will retain their original properties. You talk of color, hardness, and melting point. What about variety in composition? The composition of solid to solid mixtures can vary widely, leading to different physical and chemical properties. The composition of solid to solid mixtures can vary widely, leading to different physical and chemical properties. So yeah, the solid to solid mixtures, they have a variety of composition. They have a variety of composition because their composition varies, leading to different physical and chemical properties as well. What about the separation techniques of these solid to solid mixtures? Physical methods such as sieving, magnetic separation, flotation, or mechanical sorting can be used to separate the components. Yes, we said in mixtures, substances are not chemically joined. Instead, they are physically joined. No wonder we can separate the components of a mixture using physical methods. So since we are dealing with solid to solid mixtures, we can separate such kind of mixtures using the following physical methods: sieving, magnetic separation, flotation, or mechanical sorting as our physical processes. So indeed, we can separate them using those techniques. Um, these solid to solid mixtures that are a fundamental aspect of materials science and engineering, offering a wide range of applications due to their diverse properties and compositions. Now, we have seen that the solid to solid mixtures can be separated by sieving as a physical process. And in this lesson, we are much interested in knowing the process of sieving. So sieving is a simple and widely used method for separating mixtures of solids with different particle sizes. This is simple. This is very important. A simple and a widely used method for separating mixtures of solids with different particle sizes. Different particle sizes. It involves passing the mixture through a sieve, which is a mesh or net with holes of specific size. The process allows smaller particles to pass through the holes while larger particles are retained on the sieve. This method is particularly effective for separating dry mixtures where the components have distinct particle sizes. So, what is the description of sieving as a process? Sieving, the purpose sieving is used to separate particles based on size. Yes, the particles based on size. Removing unwanted materials or classifying components into different size ranges. The process, we have to select the selection of sieve. So you choose a sieve with an appropriate mesh size for the separation required. Then loading the mixture, you place the mixture on top of the sieve. You place the mixture on top of the sieve. Then there's the shaking or vibrating. You agitate the sieve to allow smaller particles to pass through the mesh while larger particles remain on top. Remember, this separation technique is based on the size of the particles. So if you are shaking or you are vibrating, you are making sure that the small particles are passing through the sieve while the larger particles, they are on top of the sieve. Then from there, there's collection. You collect the particles that have passed through the sieve and those that remain on top. So you're just correcting them. Those on top and those which have passed through the sieve. So this is a general overview of sieving as a process. Now, what are the tools which are used in this process? Tools used in the process. The first one is a sieve or a sifter. Sieve or a sifter. So a tool with a mesh screen or perforated plate which can be made of metal plastic, or cloth, depending on the application. So a sieve is an important tool in the process of sieving. This sieve can be made up of plastic, metal, or cloth, depending on the application. So, oh yes, you can use a sieve or a sifter which is metallic or plastic or made up of a cloth. It will depend on the application itself. So this is our sieve or a sifter, and this one is made up of metal. So as you can see, it will allow small particles to pass through and leave the particles which are bigger on top. So the smaller particles will be able to go through the sieve. What else do we have? We have a sieve shaker. Remember, on the process of sieving, there is vibrating or shaking. So we are supposed to have a sieve shaker, which is a mechanical device that shakes or vibrates the sieve to enhance separation efficiency. Please be reminded that this one is commonly used in laboratories or industrial applications. The sieve shaker. If you don't have a sieve shaker, you can use manually, you can shake it. So a sieve shaker is commonly used in the industry and in the lab. Okay, so now let us go through a video explaining or illustrating this process of sieving. So this is just a short video summarizing the whole process of sieving. How is sieving done? So let us watch the video and be observant.
Mixtures and solutions. Separating mixtures, sifting. How can we separate a mixture of sand and stones?
So you see here, we are using sand and stone. Sand is solid in nature, stones, they are also solid in nature. So if we mix them, we'll make a mixture which is solid to solid in nature. Remember, this sieving process is used to separate mixtures which are solid to solid in nature.
When sand is mixed with stones, it forms a mixture. One way of separating the mixture back into stone and sand is by sifting. Sifting uses a mesh called a sieve. Smaller particles like sand will pass through the sieve. Larger particles like the stones will not pass through the sieve.
So there, this is our sieve, and as you can see, the mixture of sand and the stones will be allowed to the sand particles, because they are small, they will pass through the sieve, while the stones will no longer pass through the sieve because they are large in size. Yeah, so as you can see, he is shaking or vibrating, so that the sand particles should go through the sieve, because they are smaller in size, while the rock particles, they will no longer go through the sieve. So shaking is just agitating the components of the mixture.
The mixture of stones and sand have now been separated.
Yeah, so as you can see, we have sand and we have rocks. So this mixture of sand and the rocks, it has now been separated. Okay, so quickly let us go through examples of sieving. We have flour milling, construction, archaeology, and food industry. In flour milling, sieving is used to separate fine flour from larger particles of bran and germ. Construction. In the construction industry, sieving is used to separate fine sand from gravel. In archaeology, archaeologists use sieves to separate small artifacts from soil. In food industry, sieving is used to remove lumps from powdered sugar or to sort grains by size. So these are just examples of sieving. Then finally, let us look at advantages of sieving. Advantages of sieving. Number one, simplicity. Sieving is a straightforward and easy to understand method requiring minimum technical knowledge. Cost effective. It is inexpensive compared to other separation techniques. Speed. Sieving can be a quick process, especially for dry mixtures. Non-destructive. The components are not chemically altered during separation. So as you can see, sieving is simple, cost effective. In terms of speed, it is just a very quick process, and it is also non-destructive in nature. So reaching this far, I hope now you know the process of sieving. It is used in separating a mixture which is solid to solid in nature, and the sieving, it is very, very important. Tools which are used, you are supposed to have a sieve, and we have different types of sieving as well, examples of sieving. What are the advantages? We have seen that sieving is simple, it is cost effective, and it is faster and non-destructive. On the applications of sieving, it is in industrial processing, quality control, mining and mineral processes, environmental science as well. So indeed, sieving is versatile and practical method for separating mixtures with particles of different sizes, and its simplicity and effectiveness make it a variable technique both laboratory and industrial settings. Okay, so reaching this far, we have an activity here, and this activity, please remember to share your answers in the comment section. The first question is, what is sieving used for? Then how does sieving differ from filtration? What factors influence the efficiency of sieving? And what are the advantages of using sieving? What are the limitations of sieving? Now for any questions, please use the WhatsApp number or help@xulendo.org, or you can visit Xulendo online, xulendo.org. Please, we need your feedback. In today's lesson, I've used the following references: Excel and Succeed Chemistry Book 1, Achievers in Chemistry Book 1, Django Chemistry Book 1, Samuel Kalia Chemistry Book 1. For the photos, these are the links for the photos, so feel free to visit the links. Well, until we meet again in the next lesson. Bye-bye.